Hello, welcome back to another Physical Sciences 3 lecture. We are looking at the structure of ionic compounds in this lecture. So, the main features of ionically bonded compounds are given below. Ionic compounds are solids at room temperature. They have a generally high to very high melting temperatures. For example, sodium chloride melts at 801 degrees Celsius. Ionic compounds consist of positively charged metal cations and negatively charged non-metal anions. The positive and negative ions occupy fixed positions in a regularly packed array called a crystal lattice. Okay, crystal structure, if you like. The only movement the ions have is vibrational motion. Each positive ion is surrounded by a fixed number of negative ions, and similarly, each negative ion is surrounded by a fixed number of positive ions. The electrical charge on the positive ions cancels out the charge on the negative ions, giving an overall charge of 0, which we saw in some examples earlier. The forces binding the ionic crystal lattice together are the strong electrical attractions existing between each ion and its neighbouring oppositely charged ions. This is the very basis of ionic bonding. Okay, we've sped that a few times already. Okay, and this is just saying that this is the structure. So we have negative anions with positive cations in a structure like this, and it's more likely to be in a crystal structure like this one. So we have the negative ones with the positive ones, negative, positive, exact, etc., etc., negative, positives, and all through we have this continuous lattice. So we're just going into that a little bit more deeply now. So explanations of physical properties of ionic bonding, of ionic compounds, Ionic compounds have high melting points and high boiling points. This is explained by the fact that ionic bonding involves strong electrical attractions between oppositely charged ions and thus require a large amount of thermal energy to be broken, right? By considering the size of the attractive forces between ions, predict which of the two ionic compounds, potassium chloride, KCl, and calcium sulfide, CaS, would have the higher melting point. So if we look at the individual ions, let's go back to our formula sheet, our information sheet, and go up here. So let's have a look at these ions. Sorry, I should have had this open before. If we look at potassium, potassium has 1, there's a 1 plus charge, and chloride has a 1 minus. So let's go back. So K plus and Cl minus, they donate 1 electron. Okay. Now if we look at Ca and S, so calcium and so we have calcium here. Calcium has a 2 plus charge and sulfide has a 2 minus charge. Let's go back. So we say Ca 2 plus and S 2 minus. And these donate 2 electrons. I'm not sure why my screen is playing funny. Okay. Screen is being a bit funny. Okay, so we can see here that because there's 2 electrons donated, the attractive forces are going to be stronger because of the more amount of electrons being donated. Get rid of this. There's no accent there or anything. So CaS will have a higher melting point. Gee, my screen is not working for me at the moment. Melting point. Because more electrons are exchanged. Resulting in a stronger attractive force. Might have to stop here and make sure my computer is actually running properly. Attractive force. Okay, we'll stop there and we'll pick up next time.